going to go into this. So we're going to look at compound inequalities. Okay? So compound inequalities, basically you're looking at two inequalities that are compounded together. Okay? Anytime it's written as such where it looks like one, you basically have these two inequalities that are written together. So I would encourage you to start by splitting them apart into two equations. So you have 5 is less than k minus 2. And then our second equation is the k minus 2 is less than 11. Okay? And then you can just solve both those. The word in between these two is and or.
Or.
Which one is it?
Or.
Does it say or?
No.
So this says I have to be between 5 and 11. What word's in between them? And. Okay? And means both have to be true. So we're looking for this overlapping region basically. Okay? So if we're solving these two equations, we'll add 2 to both sides. So 7 will be less than k. And k is less than, is less than 13. All right, so there's our and situation. If we look at this graphically now to actually graph our solutions, you know that you have 7, and you know that you have 8, 9, 10, 11, 12, 13. Okay, so there's our key pieces. I know that there's no equality, so we have an open circle. There's no equality, so there's an open circle. This one says k is greater than 7, so it's going that direction. This one says we're less than 13, so we're going that direction. With an and statement, both have to be true, so it's just the overlapping region. So my solutions graphically are everything in between these two circles. That's what our graph would look like. Okay? Next thing we're going to take a look at is if we, so if there was something like with an or is very similar, but or usually already has it written as two equations, right? You can just solve each of them individually, and as you graph them, typically you're going to have arrows that go opposite directions. And they could point at the same direction, and then they overlap, and you have all real solutions. So you could have all numbers. Or only one has to be true, and both have to be true, so you're looking at the overlapping areas. Okay, so next one we're going to look at is the idea of here's a graph, write the compound inequality for it. So for number 23, you've got everything highlighted except for -1. Okay, how could I do this? One way to do this is saying that x is less than -1. That's that part. Or what could I be? X could be greater than -1. Good. That's this part. Okay? So now I have both pieces. That is a compound inequality with or. So we have these arrows pointing opposite directions. Number 24 would be similar. Here we end up with -4, so x needs to be less than -4. That's this piece. Okay, and then this is or. And x needs to be greater than or equal to, because it's a solid circle. Okay? And then go in that direction is +2. Okay, so there's my compound inequality for 24. So ors were pointing opposite directions, and then we finally looked at this idea of open circle with no inequality or no equality, and then closed circle has that equality piece. Okay? Feeling okay there? Next one we're going to take a look at is another compound inequality, but kind of complicated and ugly. And then I think we'll finish off with a story problem. So solving each of these, justifying each step. All right, so this one is written as an or. So this will be a good example of the or situation. Just solve each. It's just two different equations. There's an equation, or there's an equation. So solve these individually. So for the purple one, we could subtract 2. 3r is going to be less than 3. R is going to be less than 1. Or we could add 10, so 7R is going to be greater than 70. R would be greater than 10. That didn't work as a greater than at all. Greater than 10. And this is our OR situation, so graphically, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, both of them have no equal sign underneath, so these are going to be our open circles. R is less than 1, so we're going that direction. R is greater than 10, so we're going this direction. And we've got everything graphed. So there's our graph for it. Questions on that? Feeling okay? This one would be similar to that first one we looked at. This is that and situation again. I would encourage you to split this up as 2 different equations. There's the first equation. Here's the second equation. So that piece in the middle overwrites it. Let's talk about this real quick because I know this got brought up. How do I bring it back into a compound statement? So, oops, that should have been my purple. That's the purple equation. So let's say we try to do this. I'm going to multiply by -4. We don't have to harass him for showing up late. That's okay. Yes or no? Okay, so we're going to multiply both sides here by -4 essentially, right? Or you could divide by that -0.25. What happens when you multiply or divide by negatives? We flip the sign. Good. So this will turn into -12, but this sign's going to flip. So now V is greater than -12. Okay? And then if we were looking at the blue equation, same idea. This -0.25 V is greater than -2.5. We'll divide by -0.25 or multiply by that -4. And so V, this gets flip-flopped, the relationship. This turns into a +10. And now if I wanted to put this back into a compound statement, you can. Okay, so basically what we're looking at is -12 is less than V less than 10. Okay, you can write that back into a compound statement if you want. Or leave it as these 2 separate ones if that helps you better. Either one will be acceptable. Okay, but you need the word "and" with it essentially. So then when you graph it, we're basically getting stuck in between a -12 and a 10 because we're going to be greater than this -12 but less than this 10. So we're stuck right in between. Feeling okay with that? And then lastly, let's take a look at a story problem. Trying to translate things from math symbols into English and vice versa. All right, so the story problem we're going to take a look at is on the back, number 31. So the absorbency of a towel is considered normal if the towel is able to hold between 6 and 8 milliliters of water. Okay, this is actually common. They'll take towels, soak them, and then see how much they actually hold in water. Okay, so they can talk about the absorbencies of these different towels. So in this particular case, my absorbency is going to be between 6. Okay, so I'm going to be greater than or equal to 6, or less than or equal, and less than or equal to 10. So I have to be between these 2. That's my normal thing. So the first 2 checks for the material are going to be 6.2 and 7.2. What's the possible values for the third reading, which we're going to call M, that will make the average absorbency in this normal period? Okay, how do you find the average of something?
Take all the.
Good. So I have 3 tests. So I want to add them all up. So we have this 6.2 plus the 7.2 plus my third test, which is our unknown in this case, m, that's our variable. And then I need to divide by the total number of them, which is 3, to figure out what our average is. Okay? So my average has to be between 6 and 8. Does that kind of make sense? So that's what we're trying to put together from this word problem. Then from here, you just solve it like normal. Okay? So you have your two equations. We have that equation, and we have this equation. Okay? In both cases, you'll have to multiply by 3. So this one turns into 18 equals 6.2 plus 7.2 is 13.4 plus our m. So we'll subtract that, which is 4.6. So the minimum reading I could get on that third reading is 4.6 on my absorbency. On the high end, let's look at the high end. We'll multiply by 3, so we end up with this 13.4 plus m is going to be less than or equal to 24. Oh, one small change here. This is supposed to be. There we go. And then we'll subtract. So over here we need to come up with an m that is somewhere less than 10.6. Okay. So essentially, when I bring this all back together, what we're saying is in order for this tau to be normal, considered normal in this average of 3 tests, I need to have an absorbency less than 10.6, but greater than 4.6 on that third and final test. Okay, so this is like quality control stuff that you do in companies to see that it fits inside of your acceptables.